Solutions of trigonometric equations. To solve the equation sec x equals 2 for x's between 0 and 2 pi, the first thing we need to do, we know sec x is equal to 2, but we know that sec x is 1 on cosine of x. That equals 2. Therefore, if we flip them both, cos x equals 1/2. That wasn't a very good triangle. 1, 2, root 3, pi on 3, and pi on 6. So in this case, we're looking for when cos is positive. So which quadrants is cos positive? The first quadrant and the fourth quadrant. Our angle, we know if cos equals 1/2, adjacent over hypotenuse, then our angle must be pi on 3. So we can say our primary angle is pi on 3, and if we want our solutions between 0 and 2 pi, our solution in the first quadrant is pi on 3, and our solution in the last quadrant is 2 pi minus pi on 3, or 6 pi on 3 minus pi on 3, and that gives us 5 pi on 3. So our solutions where sec x equals 2 are x equals pi on 3 and 5 pi on 3. To solve cosec 2x minus pi on 3 is equal to negative 2 root 3 on 3, the first thing I'm going to do is write 1 on sine of 2x minus pi on 3 is equal to negative 2 root 3 on 3. We can flip them both upside down, so I get sine of 2x minus pi on 3 is equal to 3 on negative 2 root 3. If I multiply that by root 3 over root 3, we end up with, I'm going to say negative 3 root 3 on top. On the bottom, we're going to have negative 2 times 3. That's going to give us the 3 and the 3 cancel. Oh, I've got 2 negatives in there, sorry. I'll make that a positive. Okay, so we end up with negative root 3 on 2. So to solve this equation from 0 to 2 pi, the first thing we need to do is draw our special triangle to find our primary angle. 1, 2, root 3, pi on 3. We've got sine, and it equals negative root 3 on 2, so there's root 3 on 2. Sine is opposite over hypotenuse, so my primary angle is pi on 3 degrees. However, we want it in the quadrants where sine is negative. So if we think about that, sine is negative in the last quadrant and the second last quadrant. So what I'm going to do first, I'm going to give my solutions. I get 2x minus pi on 3 is equal to, this here is pi plus pi on 3, which is going to give me 4 pi on 3. This here is 2 pi minus pi on 3, which is going to give me 6 pi on 3 minus pi on 3, which is 5 pi on 3. Because we're going to divide at the end by 2, I know I need to get another set of solutions. So if I've got 4 pi on 3, I want to find the next solution. I add 2 pi onto 4 pi on 3. So 4 pi on 3 plus, now instead of adding 2 pi, well, I am still adding 2 pi, but I've just done it over 3, so it's easier to add together. I've got 4 pi on 3 plus 6 pi on 3, which is 10 pi on 3. So my next solution is 10 pi on 3. If I add 6 onto 5 pi on 3, I get 11 pi on 3. Okay, so there's 2 extra solutions because we're going to divide by 2 at the end. Next, I need to bring my minus pi on 3 to the other side and add it on. So I get 2x is equal to 5 pi on 3, 6 pi on 3, 11 pi on 3, and 12 pi on 3. Then we've got to divide it by 2, so I get x equals 5 pi on 2, 6 pi on 6. That shouldn't be a 2, that should be a 6, sorry. So I divided my 2 across and the bottom becomes 6 for all of them. 11 pi on 6 and 12 pi on 6. Let's clean them up. I get 5 pi on 6, pi, 11 pi on 6, and 2 pi. However, we know that 2 pi is also equal to 0 degrees, or 0 radians. So that comes in as a solution as well, 0. Just to look back, if we had up here, I went around the circle twice forwards, so I went from there to there and there to there. If I subtract 2 pi, I'll also get another set of solutions. So if I subtract 2 pi off 4 pi on 3, I'm just going to show you over here in purple. Okay, so 4 pi on 3 take away 2 pi is going to be negative 2 pi on 3. 5 pi on 3 take away 2 pi is going to be negative pi on 3. So if I added those as solutions, if I add pi on 3 to both of those, I get negative pi on 3 when I add pi on 3. If I add pi on 3 to this solution, I get 0. And then if I divide them both by 2, I end up with negative pi on 6 and 0. So that's where 0 comes in as a solution down here. Okay, we know from methods that we can find a general solution for cosine, sine, and tan. From using that method, we can change cosec, sec, and cot to be in terms of sine, cos, and tan, and then get a general solution just as we have done in the past in methods. We can see here it says find all values for which cot is negative 1. So that's a dead giveaway that they want a general solution. I'm going to write cot to be 1 on tan of x is equal to negative 1. If we flip that upside down, we get tan of x equals negative 1. Now, if we want to know when tan equals negative 1, our special triangle that has 1, 1, root 2, pi on 4, and pi on 4. So in this case, opposite over adjacent is tan, so it's pi on 4. So we say our primary angle is pi on 4. Because we want a general solution, we would get x equals pi on 4. We know with tan, it is negative in the second and in the last quadrant. So if I was to get that solution there, it would actually be 3 pi on 4. So pi on 4 would be our solution in the first quadrant, but that gives us a positive value for tan. We want a negative value for tan. So our first solution is 3 pi on 4. To get to our next solution, we just add pi. So we're going to say plus pi n, where n is an element of z. So that means n can only take on, what am I thinking? Z values are integer values. So n can be positive and negative integer values, and that will give us the set of solutions. You must, as soon as you add the variable n in, you must state that n is an element of z. Otherwise, this wouldn't make sense, because if n was a half, it would bring us into the third quadrant, and tan is not negative in that quadrant. Lastly, what I would probably do is rewrite x equals, I'd put them over a common factor. So I have 3 pi on 4 plus 4 pi n on 4. N is an element of z. And then I would take out pi on 4 as a common factor. So pi on 4 is equal to, 3 plus 4n. N is an element of z. The reason I do that is if we needed to get a lot of solutions, it's easy to use this formula. If I was to let n equals 0, I'd get my first solution, x equals 3 pi on 4, because if I put 0 into there, I just get 3 pi on 4. If I let n equal 1, if I put that into there, I'm going to get 3 plus 4, which is 7 pi on 4. 7 pi on 4. So that solution there is 3 pi on 4. Then, if I go around pi, I get to my next solution, which is 7 pi on 4. If we were to let n equal 2, I would get 3 plus 4 times 2, which is 11 pi on 4. And that would be my solution if I went around another pi. And that would continue on. So a general solution is x equals pi on 4, 3 plus 4n, n is an element of z. With this question, once again, it says find all values. So we're looking for a set of solutions, not just on a restricted domain. The first thing I'm going to do, 1 on cos 2x minus pi on 3 is equal to 2. We flip it upside down, so we get cos of 2x minus pi on 3 is equal to 1/2. If we want to know where cos equals 1/2, we use our special triangle. We can see here 1 over 2, that must be adjacent, and then that's our hypotenuse. So my primary angle must be pi on 3. So primary angle is pi on 3. Which quadrants is cos positive in? Cos is positive in the first and in the last quadrant. With cos, we get nice solutions, because this solution here we can say is pi on 3. This solution here we can say is negative pi on 3. So we can say 2x minus pi on 3 is equal to plus or minus pi on 3. To get to our next solution, if I'm here and I want to get another solution, I've got to add 2 pi. Likewise here, if I want to get to my next solution, I've got to add 2 pi. So we say plus 2 pi n, and then n is an element of z. From here, I would add pi on 3 to this side. So I'm going to get 2x equals pi on 3 plus or minus pi on 3 plus 2 pi n. N is an element of z. And then we're going to divide by 2. Probably the easiest thing to do, because that's on 3. That's on 3. And that's not on 3. I'm going to put it on 3. So the top would become 6 pi n. We can also take out pi on 3 as a common factor. So I'll say 2x equals pi on 3, 1 plus or minus 1 plus 6n. N is an element of z. And lastly, we can divide by 2, so I get x equals pi on 6, 1 plus or minus 1 plus 6n. N is an element of z. Now, it might seem a little bit strange, this solution, because we've got the 1 plus or minus 1, but the reason we have that is because of the translation that occurs with the minus pi on 3. You could have split this up into 2 solutions if you wanted to. So we could have said, instead of here having plus or minus, we could have had negative pi on 3 plus 2 pi n, and pi on 3 plus 2 pi n. N is an element z. When we add pi on 3 from this side here, I would end up with 2 pi n, because negative pi on 3 plus pi on 3. And then here I would have 2 pi on 3 when I add pi on 3, plus 2 pi n. N is an element of z. Then lastly, we would divide it all by 2. So in this case here, I would have pi n, and then I would have pi on 3 plus, I've divided that by 2. If I divide that by 2, I'd get plus pi n. N is an element of z. And if we clean it up, I get pi n, pi on 3. I'm going to have 1 plus 3n, because if I put that over 3, the top will become 3. N is an element of z. And that should give us exactly the same solution. If you're unsure, we can test. Let's let let n equal 0. If I put 0 into the first one, I get 1 plus 1 plus 0. So I get 2 pi on 6. And I get 1 minus 1, which is 0. So I get 0 as a solution. If I put n equals 0 into the first one, I'm going to get, if I put 0 into these two equations, I'm going to get, so let n equals 0. Firstly, I'm going to get 0. And when I put 0 into here, I'm going to get 1 pi on 3, which is the same as 2 pi on 6. If we let n equal 1, in the first one, I'm going to get 1 plus 1 plus 6. 1 plus 1 is 2, plus 6 is 8. I'm going to get 8 pi on 6. If I put 1 into this, I get 1 minus 1, which is 0, plus 6, so I'm going to get 6 pi on 6. If I put it into the second equation, when I put n in first, I'm just going to get pi as a solution. So this is if I let n equal 1 over here. And if I put it into this equation, I'm going to get 1 plus 3 is 4, and then 4 pi on 3. And 4 pi on 3 and 8 pi on 6 are exactly the same. So you can see either method will work. They're both acceptable. It's just on a multiple choice exam, they might give either solution. So you need to know how to do both. To solve sine 4x equals sine 2x, what we're going to do first is use one of our double angle formulas. Sine 4x is equal to 2 sine 2x cos 2x equals sine 2x. Okay, you can't just divide the sine over to the other side and get rid of it. The reason being is you'll get rid of solutions. So what we need to do is take the sine 2x to the other side. So I get 2 sine 2x cos 2x minus sine 2x is equal to 0. Then we take out our common factor, which is sine 2x. 2 cos 2x minus 1 is equal to 0. So we get sine 2x equals 0, or 2 cos 2x, equals 1. I've just brought that to the other side in one step. I get cos 2x is equal to a half. When does sine equal 0? Think about a sine graph. Sine equals 0, 0, pi, and 2 pi. So I can say 2x equals 0, pi, 2 pi, 3 pi, and 4 pi. The reason I continued to go on is because we're dividing it by 2 at the end. So I get x equals 0, pi on 2, pi, 3 pi on 2, and 4 pi on 2, which is 2 pi. They all fit within the domain. Here I've got cos 2x equals a half. I'll draw my special triangle. 1, 2, root 3, pi on 3. Cos is adjacent over hypotenuse, so my angle must be pi on 3. So my primary angle is pi on 3. Cos, which quadrants is it positive in? The first and the fourth. So we're going to say 2x equals pi on 3. That's my solution in the first quadrant. If we go around to there, it's going to be 5 pi on 3. If we add 2 pi to both of them, because we're going to divide by 2 at the end, I'm going to add 6 pi on 3 to the first solution, so I get 7 pi on 3. And if I add 6 pi on 3 to that, I get 11 pi on 3. We know at the end when we divide by 2, we get x equals pi on 6, 5 pi on 6, 7 pi on 6, and 11 pi on 6, and they all fit within the domain. So our solutions here are x equals 0, pi on 6, pi on 2, 5 pi on 6, pi, 7 pi on 6, 3 pi on 2, 11 pi on 6, and 2 pi. So we have lots of solutions from 0 to 2 pi. Over here, we've got sine x on 2, we've got cos of x. We know that cos of 2x is equal to 1 minus sine squared x. Oops, I forgot the 2, it's 1 minus 2 sine squared x. So we can say cos of x is 1 minus 2 sine squared x on 2. So from that, we can replace cos x on the left-hand side with 1 minus 2 sine squared x on 2 is equal to sine of x on 2. Then bring it all to one side. So I'm going to bring this to the other side. I get 2 sine squared x on 2 plus sine of x on 2, and then minus 1 equals 0. I'm going to let a equal sine of x on 2 to make it easy to factorise. So we get 2a squared plus a minus 1 is equal to 0. 2a, I'm going to have a 1, and then a and a 1. We want to end up with a positive, so I'm going to say plus there and minus there equals 0. So I get a equals 1/2 or negative 1. And then we want to replace, we know that a is sine x on 2. So I say sine of x on 2 equals 1/2. Sine of x on 2 equals negative 1. When does sine equal 1/2? 1 to root 3, pi on 6, opposite over hypotenuse. So we know here x on 2 is equal to pi on 6. What are the quadrants are sine positive in? The first quadrant and the second. So I've got to have 5 pi on 6 as my other solution. Let's multiply the 2 across. I get x equals 2 pi on 6, which is pi on 3. And then here I'm going to get 10 pi on 6, which is 5 pi on 3. They're both in the solution. Over here, when does sine equal negative 1? If we're not sure, we just draw a sine graph. It equals negative 1 at x on 2 is equal to 3 pi on 2. When I multiply that 2 across, the 2 on the bottom cancels, and I get x equals 3 pi, which isn't within our domain. So our only solutions are x equals pi on 3 and 5 pi on 3. Okay, so between 0 and 2 pi, we get pi on 3 and 5 pi on 3. Similarly to before, we can use a substitution. Let a equal sine of 2x, so we end up with a squared plus 2a plus 2. That's the same as a squared plus 2a. A half of 2a is 1, I'm completing the square. I've added 1 on, so I've got to subtract 1 off, and then I've also got my plus 2 that I had originally. That can be written as a plus 1 squared, minus 1 plus 2 is plus 1. We can't do anything with this, it's not a difference to 2 squares, but we can substitute sine 2x back in, so I get sine 2x plus 1 squared plus 1. Now if we want to work out the range, we know the values of sine 2x are between -1 and 1. Sine let's start again. -1 is less than or equal to sine 2x, which is less than or equal to 1. If sine 2x was to equal -1, I would have -1 plus 1, which is 0, squared, which is 0, plus 1. So I'd say the lowest value is 1. If I was to put 1 into that equation, I would have 1 plus 1, which is 2, squared, which is 4, then plus 1 is 5. So our highest value is equal to 5. So our max is 5, and our min is 1. Now over here, we want to find our max and min values for the reciprocal function. So we know if I put 1 into it, I'm going to get 1 over 1, which is 1. If I put 5 into it, because that's my maximum minimum value from this function over here, I'm going to get 1/5. Therefore, my min in this case is 1/5, because it's my lower value, and my max is 1, because it's my higher value. So this function, the reciprocal function, will go between 1/5 and 1.